Yeah, I'm going to present the paper. Let me introduce myself. I am Sujatha from SASTRA. I'm going to present the paper, Performance Evaluation of Adaptive Neuro Fuzzy Inference System for the prediction of cloud service provider. Actually, the first and foremost thing is why this cloud computing became popular nowadays. The number one reason is they are providing the computing resources for the enterprises or for the personal use on demand for a monthly rental basis. So automatically, whatever we use it, we will pay for it. So if we are not using it, we don't need to pay it. So these kind of facilities are available in cloud computing, so that many of the enterprises are moving on to the cloud computing paradigm. So majorly it is providing three different kinds of services. One is infrastructure as a service, and then platforms, and then softwares. Because this infrastructure as a service, it is providing the computing resources as well as storage resources in addition to the resources. Platform services, you can develop your own application using this platform, and or you can run your application whichever developed using this platform environment. We can set the environment on demand. Then third one is software as a service. This software we can use this service for hosting our software. So companies can make use of our software. The main advantage of data moving back to the cloud by the enterprises is number one is scalability. So for an example, if we are using some servers, initially we are supporting 100 users, but it is keep on growing. The number of users may be growing to 500,000 or something else. So to n number of users. So automatically on that situation, we need to increase the infrastructure. So if we are having our own infrastructure, the main disadvantage is we have to buy for it. But after some time, if the number of users have been reduced, during that time we can't reduce the infrastructure. So this is why main reason is we can buy the service, buy the infrastructure from the cloud. So whenever we need it, we can make use of it. If it is not used, then we can return back to the cloud user itself. So whatever you are using, that can be paid. And then flexibility of the cloud computing. So automatically we can scale up and scale down services, resources is available. And then moreover thing is operation and management is very easier because it is done by the provider itself. We don't want to care about all those things. What is the cooling system? What is the server? What is the configuration? And we have to recruit a person to manage that server and everything. So that would be the headache of the cloud vendor. We don't need to go for it. And then security, this is also provided by the third party. So this is in turn will reduce the initial cost of the investment of the companies. So if I am starting a small company, so initially I don't want to invest in the infrastructure, that is a IT infrastructure, information technology infrastructure, then I should go with the cloud service. That is always better. So because of these facilities advantages, there are many cloud service providers are emerging into the market. So everybody is giving different services at different pricing policies. So the complexity in understanding the service options are very difficult by the novice user, or even though the users which has less knowledge about the cloud computing. This is the difficult task for them nowadays. So these are all the available CSPs. We have so many CSPs. I have taken only the players of the cloud service providers. And then these are all the instance types. That is the computing resources which is given to the customer. So for an example, if it is a general purpose instance, if I want to select means in AWS, it is in the form of small, large, medium, very large and everything. So the name of that thing is T5, T2, M3, M4. So in Azure, it is in some other name. In this Google Cloud, it is in some other name. Alibaba, it is in some other name. So this is very difficult for the user to understand which service is suitable for them, as well as which is the most cost efficient service also. So that is very difficult to understand. So for that only, we are going for this adaptive neural fuzzy inference system to make the decision optimally. First and foremost thing is, it is predicted based upon the history of data. Number two, since we are using the fuzzy inference system, the user input is formulated as a fuzzy engine. Okay, so that is why we will use this adaptive neurofuzzy system ANFIS for selection for the prediction of the CSP, and then we will fine tune the membership function. When we fine tune it, we can reduce the number of rules also. And normally, when we want to build a fuzzy inference system, we have to frame the knowledge base by getting the expert opinions for framing the rules. But when we do this adaptive neural network, so automatically it is formulated by the system by training it. So we have to bring the intelligence to the system, and we have to train the system with the given data, and then we have to test it. So that is possible by this neural network. So we are combining the neural network and the fuzzy system into this ANFIS. And also this is by learning algorithms, the system will learn the possibility, and then it will predict the based upon the learning algorithms. So this is very, very much useful when we want to reduce the computational complexity in terms of membership function as well as in terms of reduction of the number of rules. So it is easier, and also the intelligence. So already the previous data is analyzed based upon this. This is the previous study, which is these are the existing methodologies for finding the better cloud service provider. Since this cloud service provider selection is a multi-criteria decision making problem, so it involves multiple criterias for the selection as well as some multiple alternatives among these selection. So we have to select these alternatives based upon those criteria. But many of these existing methodologies uses these MCDM techniques, and also it uses definite QoS attributes, that is quality of service attributes are considered, and also it is mainly based somewhat it is biased because many things depends upon the expert's opinion, because the customer has to give the preference correctly, then only we will get the correct output. So in order to remove that the disadvantage, we are moving into this fuzzy neuro model. So in this, this is the workflow. The first step, we are uploading the training data, and then through this clustering algorithm we will cluster the input data into different clusters, and then we will build the membership function based upon the criteria belongs to each and every cluster. Then rules are formulated based upon the clusters and the firing strength. So we will normalize the firing strength of the each and every rule. Then we will set the consequent parameters. Then we will defuzzy the final output. So whichever rules is fired out, the average is found out based upon the fired rule strength. And then we will tune the FAS system with the given testing data. If it is the RMSE, root mean square error, is in the acceptable range, then we will stop with this prediction. Otherwise, we will tune the system until we are getting the acceptable error range. Okay. So this is the workflow of the system. So this is the adaptive neurofuzzy inference system architecture. It involves 5 layers. In the first layer, we will formulate the membership function. Some membership function here we have considered the Gaussian membership function. So based upon it, the linguistic variables are defined. These are all the membership function, degree of membership functions defined over in the first level. In the second level, it will multiplies each and every fire strength of the member functions. So automatically each and every rule fire strength is multiplied and it will get the output. And the third layer 3, the firing strength of to all the sum of the rules. So for an example, if for the given input, if 10 rules are fired out, then the average sum of all the rules firing strength will be calculated in the layer 3. And the layer 4 is for setting the consequent parameters. Based upon the output of the layer 3, the consequent parameters are set in this layer 4. And then layer 5 is the overall output, which is a summation of all incoming signals. So this is the basic structure of the adaptive neurofuzzy inference system. So the system is built, then it has to be verified with the statistical measures. The statistical measures are nothing but mean square error, root mean square error, and also coefficient determination and mean absolute error. So it is mean square error is nothing but it is average difference between the observed in the predicted and the actual value. So this is what, then root mean square, it measures the standard deviation of those residuals. Then strength of the linear relationship between the two variables is, that is from the predicted and the actual, is studied with the help of this coefficient of determination. And then mean absolute error. So in this mean absolute error, we will have this, it's a difference between the measured value and the actual value. So through the statistical analysis, we can come to a conclusion that our system is doing better. So the data set what I used for my verification of the system is our CloudOrma data set, which has 8 QoS attributes, and it has 2507 real web services data set. So the why I have taken the web services is we cannot find the cloud services data set in the internet. So it is not provided. So because the cloud service providers are not dispersing their data in public. So which is similar to this cloud service provider as cloud services. I'm taking this web services. So the attributes for consideration for analysis is these 8 attributes I have considered, because this is much more useful for the selection of the web services or else the cloud services, because based upon these attributes we can select which is the reliable cloud service provider. So this is considered for analysis purpose. And then the first step is we are doing that subtractive clustering. So in this subtractive clustering, based upon the input data, the first step, it has divided into 4 clusters. So it belongs to any training testing data will belongs to any one of this cluster. So, but we can test it with the fuzzy C-means algorithm also. But the thing is, the number of clusters formed here is, it is 5, it is 4 over here, even the number of clusters is reduced, but we have to specify the clusters in advance in fuzzy C-means algorithm. But in subtractive clustering, we don't know to we no need to specify the number of clusters. The system will itself normalize the input data and find out the feasible cluster. So it gives lesser minimum RMSE when compared to that fuzzy C-means. So the neural network which has the employs the subtractive clustering will give you better efficiency. So that is what we are going for this. And then, so in order to measure the RMSE, that is the expected versus the actual. So the meaning is the testing data. So how much accurate it is by training the model is. So we are running this up to 50 epochs. After the 50 epochs, it won't reduce much more. So it will be, so run the system for 50 epochs and then measure the RMSE error. So this RMSE error is which is nearer to 0. So just acceptable range of RMSE. So initially, before tuning the system, the input data is lying upon these ranges, but after tuning the system, it is lying inside this, and then the RMSE is reduced because of this tuning of the membership function. So we are using the optimization algorithm. So steepest descent method is to optimize the input space, and then we will train the system. So, and also errors. So error related to training error as well as the testing error. When it goes to that 200 epochs, the error rate is keep on decreasing. But when we take the validation error, so we just don't want to go for overfitting of our system. So we are running the epochs up to 200 epochs, and then we are stopping the overfitting system over here. So after 20th epoch, so up to this 20 epochs, it's keep on decreasing. After this, it's keep on increasing, and we will stop this overfitting of the system. And then when we see this actual versus predicted, initially the before tuning the system, it is not lying within this, but when after the 20th epoch, when the system is lying in the actual. So we can say that now our fuzzy model is fit into that data set. So this is what then step size. For initially, the step size is keep on increasing to the maximum level and then keep on decreasing. So the step size measures the magnitude of the optimization parameter space. So in this steepest descent optimization algorithm, we are applying it, and then we are increasing the step size and tuning the system based upon the step size. So statistical measures, as such, the statistical measures is to verify the system and justify the system is performing well with the input data. And then when we measure this R squared error to know the stability of the system, it is nearer to 1, and the RMSE, it must be nearer to 0. So it is in the acceptable range. So it is calculated, the actual and predicted is in the acceptable range. So we can say that the neural body, the learning algorithm is applied and the system model is built based upon that learning algorithms. So to conclude this, we can say that we can tune the membership function to reduce the error using this adaptive neural fuzzy inference system. And also we have reduced the RMSE and it is in the acceptable range. And the R square is also nearer to 1, which proves the efficiency of the system. And it is more accurate than fuzzy C-means clustering method. So we can justify that. I can conclude that this is more suitable method for the selection of cloud service provider. So we can predict that for this kind of data, this would be the better option for the hosting our data or application onto the cloud. Okay, so this is I just want to conclude this, and then these are all the references I have used for my work, and then thank you.